Hey guys, welcome back. So I want to talk about a pretty simple concept when it comes to programming. Something that is actually really easy to say. It's really easy to give advice on, but it's really, really hard to actually do yourself. And that's, you know what, I'll take a step back. I'll ask you all a question. Now take a second in your head and think about it. If I was to give you a programming project right now, if I gave you, here's a list of instructions, boom, 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 what are you gonna do? So step one through step whatever in your head, take a couple seconds and think, what would you do if I said, I need this done in code right now? All right, if your first answer was not ask questions and begin whiteboarding or begin developing an algorithm or just developing your plan to make the program, then that's probably wrong. The first thing you should never do with programming is do not start writing code. Just don't do it. Why? I'm going to give you a couple reasons why. I'm actually going to give you a example through a problem that I got the other day, and don't feel bad because I'll talk about the problem and I'll have you try to solve it, right? I got it completely wrong the first time I tried it. Now that I know the answer, it's a little bit easier, but I'll give you this problem and I think it will kind of illustrate my point here. So here's a rather famous coding problem. It's usually asked during interviews. It's called the Fizzbuzz problem, right? So I'll lay this out and then I want you to just pause the video and try yourself to detail how you would solve this, right? So here we go. I want a program. Now this program needs to iterate through all the integers between 1 and 100, right? So 1 all the way to 100. If that integer that it's going through is divisible by 3, I need the word fizz to be printed to the screen. If it's divisible by 5, I need buzz printed to the screen. If it's divisible by fizz or divisible by 3 and 5, I need fizz buzz printed to the screen. And if it's divisible by neither, just the number gets put on the screen. All right. Now pause the video. Try yourself to kind of work this one out. All right, welcome back. So I'm going to detail now kind of the thought process to how to figure out the whole Fizzbuzz problem. And first things first, it does not start with writing code. So a little backstory, when I first got this problem, I started by making an algorithm, right? Which kind of to what I've been talking about up until now sounds like almost the right answer. But while I was making the algorithm, all I was thinking about was how I would write this out in C#, which is essentially kind of the same thing as just starting out writing code, and I got it wrong. So from top to bottom, let's think about, first off, any lingering questions in your head that would make this not clear, perfectly clear to you. Because there's something that's really important, is the person giving you the instruction or the client that is giving you a problem that they need a solution for. The idea of what they want in their head is most likely 100% different from what you have as your solution in your head. So if I was to tell you, hey, I need a program that says fizz and buzz, what I think is right might be totally different from what you think is right. So first things first, and I think this is probably step number one, is ask questions. Immediately, don't leave anything to chance. Don't leave anything to assumption. So if you're like, well, if it's divisible by 3, divisible by 5, do you also want the number printed? How do you want Fizzbuzz to look? Anything like that. Anything that you could possibly have an assumption on, try to ask questions in the moment. Especially if you're in a coding interview, it's the perfect time to do it. Or if you're already a programmer, I'm sure you've dealt with this before in dealing with, I don't know, your boss, or like I said, a client. ask all the questions you can just to get all the possible context in that scenario. Number two would be, now's the chance where you can actually start developing an algorithm. And this is based off of the context that you've just received from all the questions you've asked. And hopefully all this is written down. So I'll kind of go through an algorithm for this Fizzbuzz. So step number one is you gotta iterate 1 to 100. So I would have an algorithm that starts with an iteration through 1 to 100, all integers, right? And notice I'm not going to do pseudocode, I'm not going to do code, I'm just going to talk through it. So step one is I needed to iterate through all the numbers. Once that's happening, or once that's happened, the next step would be to check the current number through the iteration and see if it fits one of our conditions. Now, a common fault would be is let's say if when we pause the video and you tried to solve it, what did you start with? If you got this far, did you start with checking for fizz, checking for buzz, checking for fizzbuzz, checking for nothing? What does your algorithm look like? If it branches out, that may be a problem right there. Because think about it like this. If we check and iterate through all the numbers, and then we branch out in let's say an if statement. We're not thinking about it more linearly in this situation. We branch out and say we check. All right, I'm going to check if it's divisible by 3 first. When that's done, then you have to go through 5, and then you have to check if it's 3 and 5, which you've already kind of checked for 3. It's kind of an error in efficiency. So after step 2, once we're actually checking, think about this just top to bottom. The next step should be, well, what's the most efficient way to solve the problem? First is check for fizzbuzz. Why? Because if fizzbuzz isn't met, or if just the fizz part isn't met, just the buzz isn't met, just isn't at all, you can easily just drop down and save yourself some steps in your program and maybe make your program a little bit more efficient. So if you first check for fizzbuzz, then you can see, well, if fizzbuzz, so if it's divisible by 3 and 5, if that's true, well then guess what? Print fizzbuzz to the screen, go right back up to the top of the algorithm, and just cycle through until we get to 100. If fizzbuzz isn't true, you can then branch down and say, well, what was wrong last time, or what wasn't true last time? If fizz wasn't true last time, then you can check straight for buzz, and then go back to the top if buzz was true. And then go from there. And then at the very bottom would be the scenario of none of them was true, and you're just printing the number to the screen, and you go right back up to the top to go on to the next iteration in your actual run through of 1 through 100. All the while in this process, you're just writing things down. You're making a flow chart, and once you're done with the flow chart, you're seeing if that flow chart if it actually makes sense. One of the greatest ways, and this could even be step 3 in the process of what I'm talking about, is show your flow chart, show your algorithm to someone else. Again, the solution you have in your brain is probably totally different from a solution that somebody else is going to have. So if you got a buddy who looks at your algorithm and says, well, here's a bug that you have that you might not even have known, or you show it to another friend of yours and she goes, well, this is cool, but there's a way easier way to get this done. You're going to save yourself so much pain on the back end by just showing it to somebody else, because there's an endless wealth in collaboration around you. I doubt anybody here probably codes alone, and if you do, someone's willing to help you. There's always somebody who wants to help out. So after that, after some collaboration and showing with step 3, then you can move on to step 4, which I think is making some sort of class diagram or just some sort of mock-up. That now at this point, I think pseudocode is pretty appropriate, because now you've distilled the problem to something that's pretty efficient, or something that's pretty resilient against just the code straight up breaking. So let's go with step 4 being you're making a class diagram. Now you can draw out, well how how many classes would I need? And I'm kind of speaking in my experience from C# here is, well, I need this, I need a program class, and maybe I want to handle just some nice menus. So make a menu class, and then I'll make an actual calculation class that's going to do the heavy lifting of the program. And then you list per each class what methods would you need to get that actually done. And once you're done with this, and don't forget, you can always show this one to somebody else too. But once you're done with this, now you have a plan essentially. Is now you know, well, I can focus on this class right now and I'll get this done. And I can work on this class and these methods. And then I'll move on. And what you've done is you've made kind of a top to bottom plan where as you go, you're incrementally adding a little bit more. So you take some bit of your program. This kind of dips. This methodology kind of dips into DevOps right now. So you're making something pretty minimalist, with might not be full functionality of what you want, but you're going through a pipeline, and you get it there and you get it working, and then you say, all right, now on to the next step. So you take your class diagram and say, okay, now this part needs to get implemented. You add your next bit. Oh, it works. Good, awesome. You add your next bit. Oh, it fails. Well, guess what? Since you've been going on this methodical process of drawing things out, getting things in context, working with others, and then finally, now you're coding in a methodical manner, piece by piece, per the diagrams and the plan that you've made. If something fails, you already know what it was because it was the last thing you were working on. And the troubleshooting process becomes so much easier. And you can support all this through some sort of collaboration tool. Especially if you're working with others, like GitHub is a pretty easy one that comes to mind. And you can just roll back to the last version of what you had, and now you can easily determine, oh, that was the problem. Let's focus in on this, and you're wasting so much less time. So there's a quick run through right now. If there's any improvements you see might need to be in this video, especially been a program for a while. I've been a software developer for couple months now, started a little while ago, so there's definite more to this space. Please feel free, leave comments. Always want to improve my product to help others. If this helped you, if you want to see more, you want to add more, anything, go ahead and let me know. Hope you got something out of it. I'll be doing some videos coming up that are kind of more describe what I talked about in this. So if you feel it didn't dive in too much, I'm actually going to have some videos showing actual code that I've written. Please check out, you can go to my GitHub. The link is in the description to this video. All the future projects that I'll be showing will be referencing that GitHub. So go ahead and check it out. If you want, you can follow the GitHub, and then that way you can directly follow along with videos that I'm posting. Thanks again, guys. Till next time.